we're back again. We are looking at skills from first year chemistry, and this is still 103 part 2 here. And we're looking at limiting and excess reactant calculations today. And so anytime you're looking at a problem, a stoichiometry problem that involves two amounts of reactants, in order to figure out how much product can be made, we have to figure out which one's going to run out first. And so there's a protocol for doing that, and that is to analyze what you have versus what you need. And so I'm just going to walk you through a really simple example. Again, we're going to go back to our balanced chemical equation of the combustion of aluminum. So we're going to go back to 4 aluminum solids plus 3 oxygen gas makes 2 Al2O3 solid. And a problem of this nature might start with, we'll say 15 grams of aluminum react with 40 grams of oxygen. And the question would ask, which is the limiting reactant and which is the excess? So the limiting reactant is the one that runs out first, and it's called the limiting reactant because it limits the amount of product that's made. So what we're going to do is first analyze how many moles we have of each of our reactants. So let me get a pen here. So we're going to start with our 15 grams of aluminum and our 40 grams of oxygen. So this is what we're starting with. And we can't compare grams to grams because each of them has a different molar mass. And so what we're going to do first is to convert to moles. And we'll use the molar mass for each one. And so we're going to go 15 divided by 26.982, and we get 0.556. And this is moles of aluminum. And then we'll convert the oxygen to moles. And this is 1.25 moles of O2. And then it's always a good idea to just label these answers with the word have. So this is what we have to work with. And then what we're going to do is use a mole ratio to calculate what we need of the other substance. So we would look at a mole ratio where we have 4 aluminums to 3 oxygens, and that will tell us from this much aluminum how many oxygens would we need to completely get rid of all this aluminum. So we'll go 0.556 times 3 divided by 4, and we get 0.417. And we're going to label that as what we need of oxygen. And then we'll do a like process down here, but we're going to flip the mole ratio over so that we get how much aluminum we would need to get rid of all of the oxygen. So we'll go 1.25 times 4 divided by 3, and whoops, we get 1.67, and that's moles of aluminum. So now we have what we have of aluminum, and this is what we need of aluminum. So we have 0.556 moles, we need 1.67. So since we need more aluminum than we have, the aluminum is the limiting reactant. So I always just kind of do a little cross bubble there so that I see what I have versus what I need. And then we can back that up with our data from the oxygen. Since we have more oxygen than we need, that makes the oxygen the excess reactant. Okay, so whatever you don't have enough of, that's your limiting reactant, and whatever you have too much of, that's your excess reactant. And the limiting reactant obviously limits the product amount made. So if we're asked for amount of product made, then we start with the limiting reactant have moles. And we do a stoichiometry calculation to get from the limiting reactant to the grams of product. So we would look up here and say, all right, we have identified the aluminum as the limiting reactant and the oxygen as the excess reactant. So we would bring this limiting reactant number, the 0.556, and we would bring it down here, and we would start with 0.556 moles of aluminum, and then we would go right into our mole ratio of 4 aluminums and 2 aluminum oxides. And then we would finish with the molar mass of aluminum oxide. So we're going to go 0.556 times 2 divided by 4 times 101.961. And that would give us 28.3 grams of Al2O3 could be made. Okay, so that's how we take our data and figure out our limiting reactant, and then we can use the limiting reactant moles to calculate how many grams of substance we produced. And that's it. Thanks.